We are seeing, sir.
Okay,
Yes,
fine.
perfect. You can see,
Fine.
perfect.
Okay, very good. Thank you so much. It's not going to be a long one. It's not going to be something that is too technical for us not to be able to understand. The title is Hydrogeological Investigations in Environmental Impact Assessment. The way we're going to be following it is this. What is hydrogeological assessment? Why does it matter? And when are they needed? What are the objectives of hydrogeological investigations? What is the methodology? What are the parameters that are measured? What are the key tools? And what are the impact scenarios? And thereafter, we have reporting. Of course, every investigation you have would please, if you're not speaking, I want us to mute microphone so that there'll be no interference and others can actually pay attention. Thank you so much. Yeah. Okay, fine. So I'll go to the next slide. So hydrogeological investigations for impact assessment are a critical component of environmental and engineering projects, especially where groundwater resources could be affected. These investigations are aimed at understanding the quantity, that's one, the quality, the movement, and interactions of groundwater with our environment, especially when we need to assess the potential impact of development projects such as mining, in construction, in waste disposal, agriculture, or water extraction. Now, before I go on, normally when we're mining, we usually would have a lot of need for water. And this can impact greatly the quantity or the constituent of the water that we have, basically, even though it's a renewable resource. But if the use is much more than the way it's recharged, then it becomes a problem. So why do we need to have hydrogeological assessment? Why does it matter at all? One of the key issues is that it prevents groundwater from contamination. It also prevents what we call groundwater mounding. Now, what happens in this case, when you say groundwater mounding, what does that mean? We may not be too privy to it in Nigeria, but in other mines, what happens is this. There are areas where you have what we call infiltration basins to allow runoff, to be able to run as they should be so that you reduce flooding. Now, what happens there is that during the aquifer level, if the groundwater is still in the aquifer, through the sedimentary profile, you would find the water during that runoff on that basin. It just goes slowly, and is through infiltration. It can also be, contaminants can also be removed. However, what happens is that the aquifer level now rises above the aquifer, especially when you have what we call unconfined aquifer. And I'll explain what aquifer, the unconfined, means. There are two types of aquifers that we have. We have what we call confined. The confined aquifer is usually sandwiched between, let's say, a permeable level and another under it. So contamination is less. But when you have unconfined, it just lies directly beneath the ground surface and does not have a confining layer. So what happens is that recharge occurs directly from rainfall or surface infiltration, and it makes it more susceptible to contamination. So that is the essence of, trying to say, okay, fine, let us do a study so that at the end of the day, we will be sure that these are projects will not contaminate our waters, or will not take more water than we can actually have. Third, it prevents pollution from various sources and therefore safeguards human health and the environment. Assessments such as these also help to manage groundwater levels, preventing potential flooding and damage. When are hydrogeological assessments needed. For a lot of us here who are also, into environmental impact and social, environmental and social impact assessment, would know that there is no EIA, especially when you're dealing with mining, construction, dam projects, agricultural projects where you have to use a lot of chemicals, that hydrogeological assessments are not needed. So it's important first and foremost, we need these assessments for regulatory requirements, because it's one of the things they'll be looking at. In most cases, when we are in the panel review, one of the critical areas that is always looked at is the groundwater and the surface water. In mining, for instance, which is a high polluter sector, it is important that you conduct groundwater assessment, hydrogeological assessment, such that you want to have a baseline to know that, look, when you started out, our water was potable. We don't want the situation where you will, in 3 or 2 years' time, will not be able to use our water, or it becomes, you start having conflict. So hydrogeological assessments are needed in impact assessment. It is part of the critical components that without it, going to be complete. In fact, it is one of the baseline investigations you have to conduct. So it is important as a regulatory requirement. Secondly, the assessments are often required for subdivision applications triggered by criteria such as parcel size or sensitive features. Let me give you an example. If, for instance, in most cases, a lot of plots are using the same aquifer, and then one person in a particular house decides that, okay, fine, it's a residential area, and the man decides that he wants to start doing bottled water. If you're not careful, at the end of the day, what's going to be happening is that the guy is going to be abstracting more water than is being recharged. Let me give you a scenario. Maybe 10 houses on the street are using the same aquifer, which is usually the case anyway, and one person is now overusing it. What's going to happen is the abstraction level may exceed recharge level, especially during the dry seasons, and then you begin to have issues, especially when it's being used commercially. So it's important that we carry out these assessments. They are also crucial in protecting ecologically sensitive areas from pollution. Sometimes when you're doing mining, you use some chemicals and all that. When you conduct this, it's able to tell us that, look, okay, fine, you're going to need so and so amount of water. And because you need this amount of water, we need to know your, what your provisions are for water. It's either you want to take from the surface water, if it's there, and if you want to take from the groundwater, you have to consider the environment that you're taking that from. Now, third, hydrogeological assessments ensure compliance with environmental regulations, regulatory requirements, like we said. Now, these assessments are crucial in minimizing environmental risks related to water resources. I'll go on to our next slide. Just like what we've been saying, I just put this diagram here so that you see what we're talking about. Our groundwater can be contaminated by septic tanks that are not properly constructed. In some other instances, you also have contaminant leaching, maybe from improperly managed landfills, or in our own case, we don't even have a landfill. We have what we call just a dump site. And these things are important. A lot of things that cause diseases are actually waterborne if we're not careful. And that's why, hydrogeological investigations as part of impact assessment is very, very important. So what are the objectives of hydrogeological investigations in impact assessment? The first objective is that we want to characterize our groundwater system. We want to determine the kind of aquifer type, confined or unconfined. Somebody may be quick to jump and say, okay, fine, how do you determine this? Well, a trained hydrogeologist will be able to do this, to determine whether it's confined and unconfined. We'll get to talk more about this later. The second thing under characterization of groundwater system is assessing the aquifer properties such as permeability, porosity, transmissivity, and storativity. Now, what is permeability? It is simply put, permeable, simply put to say that the ability of an aquifer material. Now, when you say aquifer material is the material that allows water to be stored in the ground. So the permeability is is talking about the aquifer material, the ability of it to transmit water. Because if you don't transmit the water that is there, then you'll not be able to also abstract that water. Or let me just say, you'll not be able to get the water from where it is on the ground to the top where you will need it. And it's therefore not useful at that particular time. So that is what permeability is. It usually depends on the pore size, the connectivity in the ground, and then it's high in quartz materials. It is high in quartz materials, and such as sand, gravel, but it has to be low in clay. If the clay is more, then the permeability is going to be reduced, and you may not be able to access the water. Then porosity, I'm explaining this because I'm using certain terms, and I do not want to take it for granted that every one of us will understand. Sorry, somebody wanted to talk? Oh, okay. And I can see Dr. Ojile. You're welcome, sir. Please, can you mute your microphone? Yeah. So.
I think I'm muted.
Okay. You're muted. You're not muted. I can hear you. All right. Okay. So I was just explaining that. I've just explained permeability. And then porosity is the percentage of spaces in a rock or sediment that can store water. And then the third one here is transmissivity, which is how much water can be transmitted horizontally through a saturated thickness of the aquifer. All these are important for hydrogeological investigations when you're conducting them. Storativity just simply talks about the volume of water that an aquifer releases or stores per unit surface area per unit change in hydraulic bed. Yeah, so the second objective of hydrogeological investigation is to establish baseline conditions. You want to know the groundwater levels before we begin to, before you complete your project or before you even start your project at all. You also want to know the water quality. You want to study seasonal variations. If your project will require water and you know that during the dry season, there may be a shortfall of water, you need to prepare for it. You cannot now say, oh, I never knew that I will not have, this is going to happen. Then we have recharge and discharge areas because it's very important. If your recharge area is something that is suspect, then you need to start thinking of what you need to do. In fact, a hydrogeological investigation can even help a project owner to determine whether to continue to site that project in that place or not. Because if you need water and the place you are has issues of water. Let me give an example. There was a place we went to in Kogi, and during the panel review, we were asked a particular question regarding, maybe they thought regarding the depth of borehole. In that area, the depth to water was like 400 meters. In fact, the Kogi State Ministry of Water Resources had to really say, yes, that is the truth. And it happens to be a mining area. So, but shortly, once you just pass to maybe like 5 kilometers away from that particular site, they have a lot of boreholes scattered. Then you'll be wondering what is happening to this area. So if you're citing something there that needs a lot of water, you're going to be facing a lot of issues because the project that you have built with millions of naira can actually become an issue for you. So it is also to identify potential impacts. I talked about that briefly. Groundwater depletion, contamination risks from industrial effluents or landfills. And if it's going to be a potential of impact, it's either you start looking for mitigation measures, which is usually what we want to do when we're doing environmental and social impact assessment to make sure. But if the adverse effect is so bad that you cannot mitigate effectively, then it is always advised that you do not go in that, because it means that your project is now going to cause an issue for the larger environment. That is not what is allowed. Changes in flow patterns. If you have changes in flow patterns in your groundwater or water system, then there may be an issue down the line if you are not careful. And in subsidence, you have subsidence risks. And let me share this with you. When you're doing mining, especially when it comes to coal, you're doing underground mining, there is this term called dewatering, because once water fills into the particular mine, you want to dewater it. You want to take away the water. Basically, as you begin to take away the water, it can lead to subsidence. Basically, you have to conduct studies to ensure that, okay, fine, your dewatering is not going to lead to subsidence, which one is going to likely even kill the people, the miners that are there, basically, and also become a particular risk. I mean, you don't want that risk there. So it's important to study this. And groundwater, I mean, hydrogeological investigations help to do that. The fourth one here, as an objective, is it supports decision making. I said it the other time. It can tell you, okay, fine, look, if I'm going to need 540,000 cubic meters of water, and I know I'm not going to be able to get it, you can just tell me that, look, I think I'd rather leave this plot or this place for something else than run the risk that is already evident. Regulatory compliance, and then the design of monitoring programs. Of course, one of the key issues which dovetails into regulatory measures is maybe in Nigeria, quite a lot of us do not, project owners don't appreciate that. But monitoring programs also, what it does for us is that it tells the environment, it tells the socio-economic part of that project that this particular project owner is very committed to safeguarding the lives and properties here, and that is very, very important. So what are the key components? If you want to carry out a hydrogeological investigation, the first thing is that you have to review existing reports, geological maps, borehole logs, and remote sensing data of that particular area, basically. The second thing is that you have to do field investigations. You have to drill some observatory wells. You do well installation, test pumping, and geophysical surveys. They're very, very important, because how are you going to get these if you do not drill, especially in an area that does not have a borehole, or even in an area where the borehole data you do not have? Let me give an example. I'm sure that maybe when people are making observations later or questions, they'll be able to get to this. Let me give you whatever. In most cases, maybe I would ask, I would be pleased if participants can tell me at the end of this, to tell me that they actually know the depth of their boreholes at home that they have, and that they have actually they've conducted tests and they've done some periodical tests on them. It would be pleasant to hear the kind of responses I'm going to get. Then water sample, we will collect and do laboratory analysis of groundwater for physical and chemical parameters. We will establish monitoring programs, establishment of observation wells for long-term monitoring of water wells, of water levels and quality. There is something that has happened, and I'll use Abuja as a reference point. How many of the filling stations that we have actually have, observatory wells for water level and quality? I'm not too sure, but I'll be pleased if somebody can just tell me that, look, we have this and all that kind of a thing. And that is why it is important that this particular project, whether it's a filling station, whether depending on the kind of things you're doing, we are able to have these wells to determine whether you're not polluting our wells, because this, from the surface water, this also percolates into our groundwater. They're interrelated. So somebody may think, okay, fine, because I let it out into the surface water, it's not going to get to the groundwater. No, it does. Then we have what we call aquifer testing. We have to do pumping tests to evaluate aquifer characteristics like transmissivity and storativity, which I had earlier on explained. Then we can now do groundwater modeling. We want to know the numerical or analytical models to predict changes in groundwater systems under different scenarios, especially for a place or a project like mining, or a project that has need of a lot of water. Then we want to do risk assessment. We want to evaluate likelihood and consequences of adverse impacts. Now, what are the key parameters that we look out for in a hydrogeological investigations? We look for the following parameters: physical, chemical, biological, and hydraulic. We talked a bit about the hydraulic, so I'll just focus on the other ones that we have not actually talked about. Physical, of course, we want to know the water level. It is important, basically. That is why in some cases, back home, you're where I come from, we had to dig like 3 wells before we actually got water. The first one that we dug is only used during the rainy season. The second one was not even used throughout both seasons anyway. And the third one was the one we now got. Well, I'm sure somebody's going to ask me a question that when they were digging it, what were you doing as a geologist? Don't worry, I was still studying in school then when they were digging it, because this is a family house. But we got to know that, okay, fine. We should have, if you want to do anything right now, maybe a bore, the first thing to do is to do a geophysical survey so that you determine, it is not everywhere in your compound or your plot that you should cite, a a bore. If you do that, you're going to meet a dry well and you'll have wasted thousands of naira or even millions of naira as it is. So physical, we want to know the water level, we want to know the temperature, we want to know the turbidity. Turbidity is, if you check water, if you want to check whether water is turbid or not, if you just take it, if it's not clear, it's turbid. If it's cloudy, it's already turbid. And there are, equipment that we can use to actually measure this particular, parameter that I've just talked about. Chemical, you talk about pH. There are equipment that we use to want to know the pH, because normally it is expected that between 6.5 and 8.5 of the pH is what is supposed to be okay, potable for potable water. That is what we expect, basically. Then we have total dissolved solids. We have major ions. We're talking about calcium, magnesium, sodium, chlorine, chloride, sulfur, and carbonate, and heavy metals, and the nutrients also. Then biological. In a lot of instances, if you think water is just clean and you did not test it, you want to know the total coliform, the E. coli, where relevant, so that you don't begin to drink contaminated water. And if it's contaminated already when you have taken it, then you have to treat it, basically. So those are the parameters we normally want to look out for. And as a baseline, you want to know whether that water actually, if we have all this, down the line, should anything happen, it also protects the proponent, because you have your baseline, which regulatory authorities can also ascertain. And that is why that is very, very important. Now, what are the key tools for hydrogeological investigation? One of the major key tools that we use is geophysical tools. You'll have heard people would say we want to do geophysical investigations. That is the essence of trying to do this. So we use resistivity surveys, which comprises of VES or vena resistivity profiling. These are quite technical, but a geophysicist or somebody who is trained in it would have to do this, so that it will decipher the depth and thickness of the potential groundwater zones, so that you do not spend money unnecessarily. So apart from regulatory measures, it also helps the project owner, or in this case, the house owner, also to be able to know that, look, oh, I'll be able to get water or will not get water. Let me not just go into something. It's better I pay for geophysical investigation and drill a bore that will cost me more than 1 million, or in some cases 2 million, depending on the depths that you're going to, basically. Then we can do groundwater modeling. We want to do groundwater modeling so that at the end of the day, the area, the region, we will know whether it suffices for us to drill, or we'll be able to get enough water for our operations. We would also have to use mapping. Basically, of course, that is a given. We have to have hydrogeological maps of that particular area to know the history, of that particular area. In some cases, I remember that some people tell you that you have to go 130 meters. And then, because the other person has gone 130 meters, you feel that, look, let me just go to 130 meters. It may be that you should have just gone 100 meters. So in other words, you have wasted money on 20 meters, because you did not do what you were supposed to do, basically. Then remote sensing. We can also use satellite imageries, but in most cases, we use this thing in combination. It's not that we just use one in isolation when doing hydrogeological investigations. So what are our impact scenarios? Since we say that, we want to use hydrogeological investigations in impact assessment, in most cases for mining projects, there is a term called dewatering. I've already explained that. It could lower the water table and it will affect nearby wells and ecosystems. What dewatering is doing is that the project owner of a mine, which is underground, when water is going into the mine, and to be able to continue to mine, he has to dewater it. So they put a machine and they draw out water and pour it into the neighboring environment. However, what that is doing is that if it is much, it could lower the water table. And once water table is lowered, it becomes an issue when for the surrounding, because it's the same ecosystem that you're dealing with. It gets to a stage, you now start discovering that your water that could easily fill your tank, it takes more time to fill your tank. These are issues that you want to really mitigate against. Then landfills. Potential leakage could contaminate aquifers. That one is a given. If a landfill fails, basically, it is going to contaminate aquifers. And landfills are just areas where you excavate them. You have to also determine whether they have enough binding that they will not leach into it. In most cases, when you have an engineered landfill, they would have to do investigations and make sure that they line it with a mud-like material, so that they will leach it to not go into aquifers. Then in agriculture, you have excessive irrigation or fertilizer use can cause groundwater contamination or depletion. When we're doing irrigation and begin to just irrigate, it's coming from somewhere. Now, when the rate of recharge is not, equal to the rate, when the rate of recharge is not equal to the rate of abstraction, then there will be depletion of the aquifer. And if you use excessive fertilizer or some chemicals, it can also lead to groundwater contamination if studies had not been done earlier on. And somebody will look at it and say, okay, but it can be remediated. I can tell you for free, sir, that groundwater contamination is the most difficult, thing to do when you want to remediate. One of the issues we're facing in the Niger Delta today is because the groundwater has been, for soil, you can do remediation. But when it comes to water, it's usually very, very difficult and it can cost millions of dollars. And if you don't have that money, it means that you cannot use that again, basically. Then in urban development, the more we begin to begin to develop, you're just developing without considering, the importance that this has on, groundwater recharge, basically, because once we have a plot, in most cases, all of us, we just do what we call add landscaping, basically, in which everywhere we have covered with concrete. And there is nowhere we have provided for some soft landscaping. Where we have for soft landscaping also, helps us to be able to, for groundwater recharge. A lot of things when it comes to environment are interwoven, because now we're talking about urban development. What has that one got to do with groundwater recharge? But I just explained what it does. Once surfaces are just covered, what it means is that water is not able to percolate into the ground for it to recharge, the groundwater. Because one of the sources of recharge for groundwater is infiltration, basically. I've just shown sources of groundwater contamination, and for all the things we've been talking about, if you can see this, you see agriculture, you will see septic system, you see municipal well, you see urban runoff, you see sanitary landfill, the industries. If the effluents coming from industries are not well treated, are not treated to the standards expected, before being let out, then it's an issue. If monitoring programs are not well entrenched and carried out in these places that is being shown on the screen, then it becomes an issue, basically. Yeah. So, uh, of course, no investigation can be complete if you don't have a report. So, what do we expect in a report? We expect we expect you to describe the study area, the geology. We expect you to give us the methodology. Then we expect you to give us your data and results, maps, cross sections, hydrographs, impact analysis. The impact analysis is okay, fine. This is what we have discovered. This is our impact analysis. What I didn't put here is a mitigation for what we have rated as our impact so that we'll be able to properly mitigate against that. Modeling, I talked about hydrogeological modeling the other time, is also very applicable. Then we'll draw our conclusions of what to do. Is it a go? Is it a no-go? And recommendations, then mitigations and monitoring strategies. Thank you. Uh, Thank you. I don't know whether Engineer Nina is around, but if Engineer Nina is not,
Yeah,
okay,
thank
fine.
you very much. I'm having issues with my
Okay,
network. That's
okay,
one thing
fine.
we need to address in this country. Thank you very much, Dr. Taiwo, for this wonderful expository on hydrological investigation in environmental impact assessment. I really believe that he actually nailed it. You know, everything he was just talking, everything that we need to know from A to Z on hydrological investigation and EIA, he actually mentioned to the point that he even told us or explained how the reporting would look like. We want to say thank you very much for these wonderful presentation of yours. And I believe that our members here listening to us will have one or two things to say or ask questions. So I believe at this juncture it's time to take our questions, if there is any. Isia, can you raise your hand electronically? Then we will be able to call you to speak. Is there anyone? Or you have words of encouragement? We will gladly take that. Okay, my Oga, Dr. Ibrahim Salam, over to you, sir. Engineer Ibrahim Salam, kindly unmute yourself, sir. Okay. Yeah,
Okay,
thank
can
you.
you hear me now?
Yes, sir, we can.
All right. Good evening, everyone. Thank you, my Honorable Vice President. I saw that our President is also here. My warm greetings
Yes.
to him and all the ESCO members here present, and ladies and gentlemen as well. So I want to start by thanking the lecturer for today for his excellent presentation. As he was presenting, there was just one thing that was on my mind. And that's something that I see all the time in our EIA reports. When I saw this topic, I was really very delighted because it is one aspect of our work that hasn't enjoyed enough attention and that is so crucial to impact assessment. So the issue that was crossing my mind is we see very often in our AIA reports that people locate 3 boreholes with the intention of determining groundwater flow direction. And that is where it ends. That is where in virtually most of the reports I have seen, they just say, okay, they dug 3 boreholes, and then the groundwater flow direction is this. My question to the lecturer, the distinguished lecturer for today is, is that where it heads? What is the relationship of groundwater flow direction to impact assessment in EIA? Because if we don't extend the analysis to impact assessment, all of the monies that we have spent digging the 3 boreholes, conducting studies to determine the groundwater flow direction would have been meaningless. So my question to our distinguished lecturer is, how can we extend, so that we can all learn from this, how can we extend the determination of groundwater flow direction to impact assessment of what is the connection, and what are the implications of groundwater flow direction to impact assessment? I hope my question is clear.
I believe so, sir. Guest speaker, please, Dr. Taiwo, would you like to take the second question and answer both at the same time, or would you like to answer this before that?
Yeah, I would like to take the second question, then I would answer both at the same time. Thank you so much, Dr. Salau, my very senior colleague in the profession. I'm glad to have you.
Thank you. Mr. Chukwemeka, please. Chukwemeka, please, can we have your
Good evening,
question?
Engineer Taiwo. Yes, good evening. Thanks, Nenna. Engineer Taiwo, I enjoyed your lecture. In fact, the way you took it, even someone who is a novice would understand you very well. Now, my question is like this. In Lagos, where I reside, we observe that over time, the residents who are close to Olushosu waste site, or rather dump site in Lagos, that is where you have the old toll gate, and the people at Solus, which is in Alimosho local government, not too far from Ikotu. Whenever we test their water, it's always high for iron, which shows that there is leachate coming in from the waste sites into the groundwater. Now, how do we carry out mitigative measures against this? That is one. Now, the second question is this. I'm also a town planner, and we are trying to develop a 5,000 square meter estate, okay? And we've gotten about 15 plots after the subdivision. Now, as a project manager, my question to you is this. Do I insist on having just one borehole for all 15 plots, or I should allow each plot allottee to go ahead to develop their own borehole, bearing in mind what you've taught us this evening? Thank you, sir.
So much.
Thank you.
Yeah, thank you so much. So I'll take the first question now. That thank you so much, Dr. Salau, for the question. The question is relationship of groundwater flow in impact assessment, given the fact that we go when we're doing environmental and social impact assessment, we drill 3 boreholes to determine the flow of water, and then what is its relevance, that we just leave it at the end of the day, we don't do anything about it. Okay, fine. It's like this, sir. The relationship of flow in the impact assessment that we keep conducting is quite important. We want to know where this water is flowing, so that whatever we want to do does not impact, in the flow. That is one. What I mean by that is this. For instance, if my flow is from north to west, from the north to the west, basically, I will want to ensure that I want to cite anything. It should not be cited in the direction of that flow, so that it does not lead to contamination. Because the groundwater flow is driven, controlled, and determined by the topography, the geology, and its climate. And so, it begins to, we have several surface manifestations. And that is why it's important for us to be able to say, okay, fine, we'll do some groundwater modeling, so that when we want to, at the end of the day, cite anything, it's important to site it appropriately so that it does not affect the groundwater flow. That's one. The second thing when it comes to the impact also for it is this. Those wells, sir, should not be left like that. It serves as a monitoring program, monitoring well for how well that particular project is doing. And in, from our own perspective, it is not every project that should, entail that you have to drill these monitoring wells. And I explain what I mean. If you are, for instance, when you have to drill such wells that we're talking about, if I'm going to do, a coal mine, I think it's important that we have a monitoring well of what you're trying to do. If I'm going to do something that is very likely, like I'm having a tank farm, for instance, I think it's important we have those wells so that we can have it serves as a monitoring well for, for that particular project, even though you may not even use it as a groundwater resource, but because the ones you're drilling at that particular moment is not going to be the one you're going to actually use at the end of the day for the provisions they're going to be making for the particular project when it becomes operational at the end of the day. That is the importance of having a groundwater having groundwater flow statistics or data in impact assessment. That is one. For the second person, sorry, sir, I didn't quite get your name. You'd have to pardon me, but I'm going to get that. You talked about Olusosun dump site. It's not a landfill, sir. The difference between that is that, and why that has happened is that, I think for a very long time. Sorry. Sorry, is somebody talking?
Go ahead, sir. Sorry, go ahead, please.
Okay, fine.
Kingsley, kindly mute them.
So the problem is this. For the Olusosun was not a landfill, because there's a difference between a landfill and a dump site. What we're having there is a dump site, and it's easy. We did that a long time. Quite a lot of places in Nigeria, not only Lagos. It's just that Lagos does not have the kind of land that other places have. The problem we face is that because waste management remains a problem in Nigeria. Wherever we find, we just throw these things, and the Olusosun became a monster. And because of that, there was nothing, to stop leachate from that particular dump site from getting into the water, resource that should not be. So you discover that every time you go in there, the things you're going to be getting are usually going to be, biological, agents. You're going to be having E. coli and so on and so forth. That's what you're going to be having. And you now have to treat that water, because if you drink it, and unfortunately, we still have issues with data. It is not everybody who has died from water-related diseases that we still have on our data or something like that. So that's the issue for that. When you said, how do you mitigate it? I am sad to say that it is not easy for you to say you want to mitigate. The only thing is that if your well is contaminated, please do well to treat it. That is the only mitigation you're going to have, basically. That's it. When we stop having arbitrarily dump sites, when we begin to have very good waste management plans, waste to wealth, waste to energy, and all that, then we can reduce some of the adverse impacts that waste management poses in the country. That is my take on that. Then I'll go into the estate that you talked about. I think it would be better because if it is, you have to do, first and foremost, you have to do a study to say, okay, fine, what is the water, what is the amount of water we're going to need, in this estate? Is it residential? Then you have to study that to say, okay, fine, these people are going to need XYZ cubic meters of water. And if they're going to need XY cubic meters of water, what do we do, basically? Remember that it's from the same aquifer that they're going to be drawing, if the 10 of them actually draw that, basically. So it'd be better if maybe 1 or 2 boreholes are dug, and then it supplies the estate. It's not more than 10, maybe 10 or maybe 12. So it's actually better to do that kind of thing. And I can tell you that on the long run, it actually saves, the estate, even a lot of money. Even the individuals who want to drill the boreholes. You drill 2 boreholes, you have very big tanks that is going to serve well the estate that you're talking about. That is the way to go. But drilling 10 boreholes, my dear brother, is a no-go, sir. Thank you.
Thank you very much. Yes, I am. Thank you so very much for that wonderful explanation to those questions. We would like to take 2 more, Mr. Shetima Booker and Mr. Paulinus Akpabio. So, Mr. Shetima, over.
Okay, good evening, everyone. Okay, thank you, Doctor, for your time and your effort being put for this lecture. I really enjoy it. I learn 1 or 2 things, but I have one question that I wanted to raise concerning hydrological flow regime. The question goes like that. What are the parameters required to determine the impact of hydrological flow regime of a river? And how do I get these data? Is there any secondary source to obtain these data? Let me take it again. What are the parameters required to determine the impact of hydrological flow regime of a river? And how do I get this data? Is there any secondary source of such data? Thank you, sir.
So can we get Mr. Paulinus so that he can answer the 2 questions? Okay. We also have questions online on the chat.
Okay. Okay. Good evening. My name is Paulinus Akpabio from MSc student from University of Calabar. I want to know, thank you very much, Dr. Taiwo, for your presentation. I really enjoyed it. I want to know, you have talked about the environmental impact assessment. How do we remedy oil spill site, maybe a well, hydrological well that have been contaminated by oil spill? How do we remedy that? Because I've actually been to a site that the whole community in Akwa Ibom State, that I'm told that they don't, when I carry out record disaster survey, I was told that they can't use the water there because of activities of oil pollution. And I went back to the university, though I will be going back there again to take samples, but I have been asking myself, how can one get a potable water from, because the whole of that community, a certain community, I'm told that there's no potable water, the water is not good to be used. So when I heard your presentation, I would have loved to know a way that we can remedy well that have been contaminated by activity.
Over to you, Doctor.
Thank
Dr.
you.
Taiwo.
Yes, I'm with you.
Thank you.
Thank you so much. The first speaker spoke about, water flow. I think I know how to get that, because what he said was, what are the parameters that you would use when it comes to hydrogeological flow or water flows? I wanted to get that well. If you could speak to that, I'll be pleased. Basically, I want to get that, because I have. He was talking about the parameters. I know the parameters to say, but I just wanted to get his question better. I understand the second question, and I can actually just address that immediately, but I would like Mr. Shetima, right? To please.
Okay, can I come again?
Please go ahead.
Okay, thank you, sir. I'm asking, what are the parameters required to determine the impact of hydrological flow regime of a river?
Okay,
So,
good.
yes.
I get you. I get you.
Then in extension, I say, how do I get this data? Is there any secondary source in which I can get this data to identify the alteration of the river flow by by weather indicators of the hydrological characteristics of the river?
Okay, fine. Thank you. I think I'll take your question quickly. The first thing
Sorry,
is that
Dr. Taiwo, can I
yes,
just chip in here? Even though the question is very relevant, but the topic is hydrogeological. But the question is specific to surface water. In situations where you want to know whether it's a laminar flow or a tubular flow, but those may not be very, very relevant to the topic for discussion, but he will still give you his responses. But one thing that is obvious is whether it is hydrogeological or it's hydrological, the flow regimes are almost the same, except that within the groundwater system you have barriers, unlike surface water where the water flows freely on the surface. There is a connection between the two also. If you all know River Ethiopia is one river that the source is actually from groundwater, an artesian well. There are a number of rivers that sprout from artesian wells. People now take it to as grooves and they do ancestral worship and what have you. So there is a link between the two. But in this, for us to really appreciate this lecture, let's see if we can limit our listening to the hydrogeological aspects of the EIA investigation. Hope that helps.
All right, thank you, my president. So I will just take his question nonetheless. I think first and foremost, you can get data from the Nigerian Hydrological Services Agency. They are the ones that actually are responsible for having water resources data, and that is the agency you can actually get that from. That is one. Now to your questions regarding you want to know the parameters. It's a very simple thing. Basically, you're looking at the I flow rate. You're looking at the I flow rate, the variations in flow rates. That's what you're going to be looking at, basically. You're also going to be looking at your geomorphological processes like shape river channels and floodplains, and that's what you're going to be looking at. And it's not something you can just get in a while. I like the fact that you say where you can get that data. It's a study that you have to carry over time using flow equipment to be able to determine that. So it's at the end of the day, you're going to be looking for temporal patterns of high and low flows that can extend for several years. And that is why it is the best agency to give that to you would actually be the Nigerian Hydrogeological Services, because they have data spanning several years. For you to get a flow regime, it usually spans the hundreds of years. That is how that you can actually get that. So you'll be looking at temporal patterns of high and low flows over 100 years for you to really determine what you seek to do. I would not know whether Mr. Shetima is running a particular study. Maybe that's why he's asking that question. Yeah, if that is the issue, we can take it further after this webinar so that we can provide further assistance to you. But that is that. Thank you.
Thank you, sir.
Thank you, Doctor, for answering. And we have some questions on the chat. Unfortunately, I don't know if you can see it from your end. The internet took me off and brought me back, so I lost it. So if you don't mind, sir, maybe you pick one or two to answer.
Okay, let me go there. Okay. What is the implication of siting too many boreholes in an area when it comes to urban development? I'm going to go straight to it. What is going to happen is that you're going to have, you know, a depletion. You know, what you're just going to start having is that the water table, the groundwater table is going to be lowered. And I said something at the same time. You're going to be abstracting more than the borehole can recharge. You know, and very likely you may definitely have a shortage of water during the dry seasons. That is that's the implication of siting too many boreholes in an area when it comes to urban development, because you're going to be abstracting, taking water from the same aquifer. And I know how we use water. Anybody, the ones that just use water, some guys even leave their boreholes running because it's residential. So you've got to be careful that you do not do that. At the end of the day, you're not going to have effective supply. Everybody has a borehole, right? But at the end of the day, you start discovering that, especially when it comes to dry season, the boreholes are not going to be as effective as they should be. Okay. Now, he said, there's a question that says, is there danger in having a canal close to boreholes residential use? The canal you're talking about, what is the depth of the canal? What is the width? For a canal, I don't think a canal is going to be quite big, basically, unless there's no danger in having a canal close to boreholes residential use. Once the canal you're talking about does not have contaminated water running through it, but that cannot be said of, of the canals that we have. A lot of very funny things actually go into these canals. But a borehole is not something that is like a normal well. You know, it's not like a normal well. It's only well that can have that this kind of canal can pose danger to. The boreholes that we're talking about usually are several tens of meters away. Usually, like maybe in some cases you have some 60 meters, in some cases you have some 90 meters, in some cases it can go as high as even 400 meters in some cases. So, but if water flowing through a canal, now before it can get to the groundwater, there is also this natural curative measure that nature has provided for. If it's flowing through in there, if it's flowing through a place that is permeable, there will be some decontamination as the case may, or purification as the case may be. So I do not see the danger in having boreholes, a canal close to residential use. I don't think those are the ones I can see. Okay, somebody said, thank you for your presentation. In addition to the usefulness of boreholes helping to determine direction of flow ahead of the project implementation, knowledge of direction of flow also helps to determine how to monitor and track like the direction of movement of contaminants should the groundwater contaminant occur in that area in the future. Yes, is what we have actually talked about. Thank you so much for that comment. Somebody said you mentioned map as one of the reports, and I was wondering the extent of mapping or map. While you explain further, I want to say that it should not be limited to the location map, but should be extended to delineation of the subbasin as well as digital elevation model to determine flow direction using RS. It is unique mappers network that said this. I just wanted to read that out because it's a contribution to what we have done. And part of what we were saying when I was giving the lecture was also to say that you can use maps, you can use remote sensing, which is satellite imageries, but you need to be studied in that, or you'd have to you'd have to employ somebody who is an expert in that. I think that is where our unique mappers network colleague comes in. Thank you so much. I can see another hand. One Madam Teresa Olayinka is raising up her hand. I don't know whether you want to ask a question. You can please go ahead.
Yes, I do. Doctor, thank you very much for that beautiful presentation. And my question
Madam
is...
Teresa Olayinka Ajiboye, can you speak now? And that will be the last question for today, please.
Yes, I'm already talking. I don't know if you can hear me.
I hear you loud and clear, ma'am.
All right, thank you very much. I said my question, is on boreholes that we dig in our compounds and all that. We'll be hearing that we should move it away from sockaway and all. Then I also heard that they do casing in boreholes. So what's the usefulness of this casing if boreholes and aquifer can still be easily contaminated? I was thinking that the casing is to prevent contaminants from getting into the water or the aquifer from where the water is coming out from. I don't know if you get my question.
I get your question, ma.
Thank you.
I get your question, ma. First and foremost, thank you for that question. I think it's like this, and it's a question that will bother a lot of people. Let us say you have a plot that is no more than 500 square meters. Now you do a geophysical investigation and the design is already there, so you determine, you want to look at it to say, okay, fine. When we were talking about flow, that is the essence of what we're talking about. Water, the flow of water, even through the soil. You want to know how water is going to flow, the direction in which it's going to flow. If, for instance, I locate my borehole in the southern part, and my sockaway is actually in the northern part of my plot. The sockaway we're talking about, maybe you're talking about 3 meters. The borehole you have built is like maybe 90 meters or so. Before what is coming out of this, the way the septic tanks are constructed, it is not expected that there will be contamination to the borehole of 90 meters. Another thing I want to say, when you're in a sedimentary area, in Abuja, we're not in a sedimentary area, where the majority of where we are is actually basement complex. So basically, what they're saying, somebody that is saying that you should move borehole from one place to the other. Borehole is not something that is like a public toilet that you can just easily move. So I'll say that the likelihood of that being contaminated, if you don't have, if you don't have an external, body that, is having, that has become a source pollutant, the likelihood of having that is very, very low. That is one. Secondly, sorry, please, could you mute whoever is, thank you. So secondly, you said casing. Yes, there is no borehole that you will not case. If you don't case that borehole, it's going to collapse, and then you would have to start another process of, rebuilding or reconstructing a borehole. So casing is needed so that surrounding walls of the borehole will stay. When it gets to the the aquifer, there are nets, there are other things that are put there. I mean, the pump, so that it can go. But why it has to be cased? So that it's not, if you don't case it, forget it, water is not going to get to you. And when it gets to you at all, it is just going to be, you start having mud and all that kind of thing. Then it collapses fully. And then the pump, once mud and everything goes into it, the pump is going to get burnt out. And that is it. So that is the essence of casing, to ensure that water is able to be abstracted properly from the borehole that you have dug. Thank you on that. There was a gentleman who asked the question. I'm so sorry I did not. I just remembered now. The person is talking about how you want to remediate groundwater. I hope the person is online. Maybe I just wanted to make sure that I did not. I remember just now. Remediating groundwater, I've said it before, sir. Remediating groundwater is one of the most difficult things you can ever investigate. The best thing to do is just cap that borehole and abandon it, basically. If you do not, otherwise, what you'll be doing, somebody is just going to be telling you that I can do it, and it's not an easy thing to do. Soil, if an area is contaminated and it's soil, it's easier to remediate. But when it comes to groundwater, I'm not too sure of how you want to do it. One of the first things that has to happen, even if you want to do anything, is that the source of the contamination, has it stopped? Basically. So if it has not stopped, what are you going to do? We had an issue like that and I can mention it because an issue like that in NNPC towers, the borehole, we advise that the borehole should be just capped and should be discontinued because we're finding, oil every time the ball comes up. Oil is going to be part of what we're getting. So my advice on that is either you just decide to abandon that borehole totally. Otherwise, remediation will just be a waste of money. That is my take. I hope I've answered that question, sir. Thank you. Thank you so much.
Thank you so very much, Dr. Taiwo, for this wonderful and amazing topic that you brought to us. And I believe we all learned, and some of us we learned, and some of us also unlearned. And for me, as a water engineer, of course, I learned so much. I want to say thank you. We will take this beyond here, like he said.
I'm sorry. I think engineering is having network problems. I can't hear. Can every other person hear? Can anybody hear engineering? She's our moderator. So if anybody is around too, I don't know.
Okay, I can hear him, the engineer. I can hear engineer.
Okay, you can hear. All right.
Yes.
Okay, thank you. And like I said if we need to take whatever things we need to take outside the conversation here today, I'll be willing and available to provide, resource because we're here to learn from each other and also to assist each other in the Association of Environmental and Impact Association of Nigeria, and that's what we're here for. So thank you for the opportunity to actually deliver this. I've also learned there are certain things now that you have penciled down, and I think I'm going to go back, even look at them, and I'll be able to. So I think I'll be able to, just work with anybody who has a further need or clarification, as the case may be. I can also take it to my other colleagues, and we can look at it and provide solutions for you. Thank you so much, and God bless you all. Unfortunately, not unfortunately, engineering, who is actually a moderator and anchor, is having network issues. So if we do not have any particular questions any further or any observations, I would just want us to call it a day, if you do not mind. Thank you so much.
Okay, Doctor, let me just seize the opportunity of being present for this segment. Just offer some little news like this. Close the session. This I should have done at the beginning of the seminar. I apologize for that. I just want to use the opportunity, this forum, to thank you for accepting to present this interesting topic. I also want to thank Ibrahim Salau, the International Chair for Training, and I'm sure that while he's writing his reports, he will also let the international community know that the Nigerian Association is doing our best to see that we initiate these trainings and see how we can create more. The trainings is very, very important, and I would want to say that even the ones topics that we have had before, we can repeat them since it's a continuous learning process. As a hydrogeologist myself, the topic was quite topical and very, very necessary in this point in our growth. Groundwater happens to be one of those areas that is hardly regulated in this country, as against what obtains in maybe other developed climes. I just want to share, let's say, 2 or 3 examples of how groundwater issues were used in determining the outcomes of some projects in the course of my work on the show developing EI activities. One is, you all know the Nestle water project in Abaji. The water is going to be abstracted from groundwater. Then there came a time when the Indomie group wanted to build a cold slurry plant opposite the water basin, and they also want to use a huge amount of water. And we were able to determine from studies that they will there will be over abstraction of the aquifer. So we stopped that project. Then the Nigerian LNG project is also one project that groundwater was, the flow rate was used in forcing the company to go back to the drawing table and then redesign the engineering, because the trains 1, 2, and 3 were to use groundwater for their cooling. And it was, from the studies that we carried out, we discovered that the further trains there, trains 4, 5, 6, and even 7, may not be able to rely on groundwater, so they had to use air cooling. Let me just round up by saying that, groundwater is so important to us in the world. Civilizations in the past had been eroded, because of this matter. The Aztecs, civilizations in the Sahara, and whatever. Even in America in the 20s, when the Ogara Aquifer was over abstracted, it created a serious famine for farmers there, which led to the Great Depression that brought down the economy of the entire world. So I want us to see how we can take groundwater issues much more seriously as environmental practitioners. So with this, I don't know if Janina is able to come back on. Well, and again, I think I saw the immediate past president on the listen. I'd like to welcome her and to thank everybody that has participated in this webinar. Thank you very much.
Thank you, dear President, for your remarks. You'd always be our senior colleague. So, sorry, Dr. Emmanuel. Is there anything? Okay, please. You'll be the last person, sir, so that we can wrap up. Thank you.
All right. My own is just a comment and a request. I don't know if it's possible for us to have the slides shared, whether we can drop our respective emails on the platform, or I would like to have these slides. I don't know if it's possible.
It's very possible, sir. There is nothing. We all of us are, trainers and assistant trainers and collaborative trainers. So right. the slides will be shared, sir.
Thank you very much.
The emails can be dropped. We'll share that. Thank you so much. Yeah. All right. Thank you so much. I want to also say my own Thanksgiving to. I want to thank the president, Dr. Abbas Suleiman, for giving the opportunity to do this. I want to thank the Vice President, Engineer Nina, for the opportunity to also do this. And for everybody who took our time, I can see 32 people on the call to do this. I also want to thank Professor Ijoma for being on this call and every other person. I want to thank Dr. Ibrahim Salau for being on this call. I want to thank him so much because he's been the pioneer when it comes to all this, and will continue to build on what he has already laid. Thank you, and God bless you all. Have a wonderful weekend. Thank you. Bye-bye.
Thank you. Bye-bye.